The second classification is relative direction of fluid motion. So based on the relative direction of fluid motion, there are three types of heat exchanger: parallel flow, uh, counter flow, and cross flow. The first one is parallel flow heat exchanger. In parallel flow heat exchanger, we know, like the name, it is parallel. The hot and cold fluid flow parallel to each other. The flow arrangement and the variation of temperature of the fluid stream in case of a parallel flow exchanger. Also, the two fluid travels in the same direction, and the two stream enter at one end and leaves the other end. So we can see the hot fluid and cold fluid entering to one part and leaving the other part. And one thing you have to keep in mind is the temperature difference between the hot and cold fluid goes on decreasing from inlet to outlet. Why? It's because the hot fluid temperature decreases and cold fluid temperature increases due to heat transfer from cold fluid to hot fluid to cold fluid. Okay, along the length of the heat exchanger, this will happen. That is what shown in that graph. It's a plot between temperature. So the graph is plot between temperature and length, and Th1 is the initial temperature of the hot outlet, and Th2 is the final temperature of hot outlet. Similarly, Tc1 and Tc2 of the cold fluid. So Th1 decreases along the length, and it decreases at Th2, while Tc1 increases to Tc2 due to the gain of heat from the hot fluid. So this is what is a parallel flow heat exchanger. An example are oil coolers, oil heaters, and water heaters. This is simple working of a parallel flow heat exchanger. In the case of a counter flow heat exchanger, the two fluids flow in the opposite direction. Okay, look at the figure. The hot fluid and cold fluid enters in the opposite direction. Inlet of the cold fluid will be the outlet of hot fluid. That's how it is arranged in a counter flow heat exchanger. The temperature difference between the two fluids remains more or less nearly constant in a counter flow heat exchanger. In addition to that, the maximum due to counter flow, the maximum rate of heat transfer of a given surface takes place in a counter flow heat exchanger compared to parallel flow heat exchanger. So that's one of the main point of counter flow heat exchanger. That due to counter flow, the maximum rate of heat transfer takes place, and this type of heat transfer is mainly used to heat exchanger used for heating and cooling of fluids. The figure shows that Th1 temperature Th1 decreases to Th2 along the length, just like parallel flow heat exchanger, but Tc2 we have to look in the opposite direction, because the outlet of cold fluid is the inlet of the hot fluid, right? So Tc1, from the outlet of the Th2 is the cold fluid is entering. Therefore, we have to look in the opposite direction. Tc1 is the inlet of the cold fluid, which is at the range of outlet of the hot fluid. So Tc1 temperature increases to Tc2 along the inlet of the hot fluid. Okay, that's what we have to. That's why we get this figure. Okay, and we have to put the arrow in the opposite direction just because of the counter flow. So this is a diagram of temperature versus length of a counter flow. Third one is a cross flow heat exchanger. The two fluids, hot and cold fluid, is cross each other. Okay, there will be a crossing between the hot fluid and cold fluid, and could be in just like that spiral shape, or could be in right angle. Anyway, the hot fluid and cold fluid cross each other. Hot fluid will be flowing in one direction, and cold fluid will be flowing in other direction, intercepting the other fluid. Okay, the point to be noted is hot fluid is flowing in a separate tube. We can see each tube shown in different tubes. Hot fluid is flowing in a separate tube, so there is no mixing of fluid stream. Okay, the hot fluids are flowing in a separate flow, but the cold fluid is perfectly mixed. You can see there is a crossing between the cold fluid, so that line shows the crossing. So cold fluid is it is perfectly mixed at this flow through a exchanger. Okay, and the temperature of the mixed fluid will be uniform and will be vary only in the direction of flow. Example, cooling unit of refrigeration system. So this is a cross flow heat exchanger.